Some important features to be looked at in a radio receiver are its sensitivity, selectivity, fidelity, adjacent channel and image interference, automatic volume control AVC, squelch, and signal to noise ratio. Sensitivity is the ability of the radio receiver to pick up weak signals. Lower the signal needed in the antenna circuit to have good audio output, higher the sensitivity of the radio. Sensitivity may range from microvolts to millivolts of signal in the antenna circuit and depends on the number of amplification stages in the radio and their quality. Selectivity is the ability of a radio receiver to separate the signal of the intended station from those operating on other frequencies. We need the reception bandwidth to be narrow, yet it should not cut off the upper and lower audio frequencies modulating the received signal. Selectivity can be improved by having more tuned circuits of higher quality in the receiver. Fidelity is the quality of reproduction of the received signal in the output. High fidelity would mean lower distortion introduced by the radio in the received signal. Adjacent channel interference, as the name implies, is interference caused by signals near to the intended frequency in the receiver. It could be due to improper tuning of the radio and sometimes due to poor frequency control in the transmissions like drift in the variable frequency oscillator VFO frequency. We observe this problem in amateur radio mostly on contest days when there are plenty of stations using the limited frequency band available. If another SSB station is operating at less than 5 kHz difference, adjacent channel interference is quite common. Very strong stations can interfere with reception of weak stations on a nearby frequency. In case of broadcast stations, nearby frequencies are not allotted to stations operating in regions where adjacent channel interference is likely. Interference by image frequency is a feature noted in super heterodyne receivers when two station frequencies are separated by exactly twice the intermediate frequency of the radio. Both these signals produce the same intermediate frequency output from the mixer stage. Image frequency interference is prevented by using a good filter at the initial RF amplifier stage. Use of double or triple conversion super heterodyne receiver is another option as discussed earlier. Higher first intermediate frequency in these radios increase the spacing between the image frequency and the intended frequency. That makes filtering out the initial RF amplifier stage easier. Image frequency interference is more likely in shortwave than on medium wave bands. The ratio of the output signal to that of the undesired image signal is known as signal to image ratio or just as image ratio. Automatic volume control, also known as automatic gain control, maintains the same audio output despite variation in incoming signal due to fading. Fading is common in shortwave signals traveling along different paths from the transmitter around the earth. Automatic volume control prevents overloading of the receiver when the signal is strong. The average or peak output signal level is used to dynamically control the gain of the amplifiers so that the circuit works well with a greater range of input signal levels. Automatic gain control reduces volume if signal is too strong and raises it when the signal is too weak. Feedback control signal is usually taken from the detector stage of the receiver and used to control the gain of intermediate frequency or RF amplifier stages. Appropriate filter circuits are needed to prevent the audio component of the signal from the detector stage producing distortion by overmodulation of the received signal. When there is no signal being received, a sensitive receiver can produce significant noise because automatic gain control disappears in the absence of any carrier. Receiver becomes more sensitive and amplifies any electrical noise present in the input. This is especially more in FM receivers, which produces a hissing noise when the squelch is kept open. The circuit used to quieten the noise while no signal is being received is known as squelch. Usually, a volume control-like mechanism is used to adjust the squelch level. While receiving weak signals of amateur radio satellites, squelch is intentionally kept open as the weak signals from satellites may not be enough to open the closed squelch. Powerful signals from satellites like the amateur radio on International Space Station may be able to open squelch in high elevation passes when the satellite comes near overhead. Signal to noise ratio, or SNR, is the ratio between the power of the desired signal to the power of background noise. SNR is often expressed in decibels. An SNR higher than 1:1, meaning an SNR more than 0 dB, indicates that signal is more than the noise. A good communications receiver should have an SNR of 5 to 10 dB in bands below 30 MHz. A high SNR means that the signal is clear and easy to detect or interpret, while low SNR means the signal is obscured by noise and difficult to interpret. SNR can be improved by different methods like improving signal strength, reducing noise level, filtering out unwanted noise. It is known that a delta loop antenna has a low noise level compared to conventional dipole antennas. Signal strength can be improved by directional antennas if the direction from which the signal is coming is known. Noise level can be reduced and signal strength improved by adding low noise amplifiers (LNA) at the antenna output before the receiver input. These two techniques are used in satellite communications where the signals are expected to be of low level. What remains is mounting this antenna and starting to test SWR, tuning. All those are tough jobs. I'll do it on another day.